This is a screencast for parallel and perpendicular lines from equation. In this lesson, we would be able to identify the slope and y-intercept of a parallel or perpendicular line when given an original equation and a point on the new line. We also, when given two equations of lines, would be able to identify the lines as parallel, perpendicular, equal, or the same, or none of the above. Within this lesson, you should be able to identify slope from equations of lines, and that includes manipulating equations of lines. And then after this lesson, you would be prepared to write equations of parallel and perpendicular lines. So to review, parallel lines are lines with equal slopes but different y-intercepts. And we also need to remember that all vertical lines are parallel. Perpendicular lines have slopes which have a product of -1, or if we take that a step back, they are lines with opposite reciprocal slopes. And keep in mind that vertical lines and horizontal lines are perpendicular. Equal lines are also known as identical lines or the same line. And they are lines with the same slope and the same y-intercept. And then skew lines, or the neither or none above, are just lines that are not parallel, not perpendicular, or not the same line. So let's take a look at this first example. We're given a line and we're given a point, and we would like to find the slope and y-intercept of the line that is perpendicular to our line in blue, and make sure that it passes through the point 3, 4. So the first thing I'm going to do is highlight that the slope of my original line is -3/2. Now, the slope of any line perpendicular would be the opposite reciprocal. So our original line is negative slope, so I would need a positive slope, and the reciprocal of 3/2 is 2/3. So the slope of my perpendicular line is 2/3. In this case, because I am given a grid, I am just going to draw the line on the grid to determine the y-intercept. Now we are given a slope of 2/3, which positive slope would look something like that. But that's not going to be useful if I'm going to draw the y-intercept. So we can think of our slope that way. So instead of moving up and to the right, we could move down and to the left. So that's what I'm going to do. And there's my y-intercept. So my y-intercept is at 0, -2. So there would be the line that is perpendicular to y equals -3 halves x plus 5. And now we have our new slope and our new y-intercept. Now, when we are comparing two lines without a grid, to approach this problem, I think the easiest thing to do is just to rewrite them in slope-intercept form. So let's take a look at each of these lines, and I'm going to manipulate them so that they're in the form y equals mx plus b. So I'll start with my line on the left, subtracting 4x, and then dividing by -6. And when comparing lines, we need to make sure that our lines are completely simplified. So when we manipulate our top equation, we would get -2/3 x minus 5/3. I'm going to do something similar to the equation on the right, or the bottom equation. Add 6x to both sides, divide both sides by 9, and then make sure that my fractions have been completely simplified. So as we're looking, both of those equations appear to be the same. So I would describe these lines as equal lines. So in this lesson, we went through two examples. One where you're just trying to find the y-intercept and slope, and the other one is actually comparing the two lines.